Is your building ready for the world of EVs? Today, we're taking a look at bringing the high rise up to speed without tearing out the walls. Welcome back to another episode of EV Charging Minute. I'm Tony Booth, your host and the founder of Stay in Charge, bringing this podcast to you every week to just share some knowledge about commercial EV charging, helping you maximize, the ROI that you get out of it, installing electric vehicle charging at your commercial properties. And we just try to look at different things we run into. We learn a lot every day. It's a newer industry, obviously, right? EV charging hasn't been around forever, and so a lot of people have a lot of questions, and we're solving a lot of problems. So are a lot of other companies out there. There's just new stuff happening all the time and everything. So that's why we like to come out here today and bring this stuff to you and share and answer questions, because there's really not a great place as you look around to find answers, right? Like you could Google a lot of this stuff and nobody really knows the true answers yet a lot of times. And so there's some stuff you read and if you've done any research on this stuff, you'll see conflicting stories, and you'll see a lot of stuff out there, I guess, is something I noticed early on. And I spent a lot of time chasing things and thinking that, something somebody was saying, like, well, oh, we can, our chargers are twice the speed. And I'd go look and try to figure it all out. And it's just, there's a lot of stuff and there's a lot to take in, and people like to just say things in certain ways. And so that's why we started this a couple years ago. I just want to share this information, and what I'll do is shooting you straight with what we know, what we're doing, what we see, so that you can ask the right questions, right? Like you can, no matter who you're working with, whether you're working with us at Stay in Charge or you're, working with some other CPO out there, or your local electrician, or, whomever it is that you're talking to, you can make good decisions. And so that's what we're here for. So what I ask, though, everybody that's here, I'd love to hear from everybody that has questions or thoughts or things that they're struggling with. Be glad to share more information and find out about that. And also just hit that subscribe button, share this with anybody in your organization. If you stumbled upon this and, maybe it's other people in your organization that deal more with this, then share it with them and say, hey, here's some stuff to learn about EV charging. It is a good way. We have this podcast that's every Friday. And we also have, if you go to our YouTube channel, we have a whole series of mini shorts, basically, 60 to 90 second little short videos that give little tips, little ideas, things about what's going on. Just those are more guidance, kind of give you ideas to think about. When the podcast, we dig a little deeper. You'll also find a lot of little clips off of the podcast all over. So anyway, just want to let you know what we're all about. As always, reach out. You can find me anytime, Tony Tonyb at stayincharge.com. You can, send me an email. I'd be glad to connect and answer any questions direct. And our team's always there to help as well. So today we're talking about, like, kind of a high-rise building is where this first came about, but this does apply to a lot more than that. We'll talk a little bit, as I'm going through, we'll share a little bit of how it impacts other buildings as well. But, the initial thought process here was to talk a little bit about what happens in a high-rise, because you are kind of in some constraints there, right? If you think of a typical high-rise, in an urban dwelling, in an urban setting, you're going to have probably some parking decks and, some things like that on the ground floor, maybe even underground. And then above that's going to be, like maybe your multifamily condo complex. So those have constraints, right? There's not a whole lot of space. You don't really have, you don't have a big open parking area to throw chargers in. You don't have a big, kind of green space to put new transformers in or bring new services in. So you run into a few additional challenges there, not just from electrical capacity, but we're going to talk a little bit about, how you install them and things like that. You get into, the structural components, the fire safety components. There's several things to really pay attention here. So make sure that you are working with good people. So we're going to start looking at this. We're going to look at, basically look at kind of the power supply side of things. We're going to look at the, design and installation considerations, and then we're going to finish off with talking about the right power management tools. But when you think about the foundation, that's kind of like not the foundation that your building's built on, but the foundation of your electrical system, which is really important here, right? If we need to power chargers, we need to have available power. So that's one of the first things that we need to look at, right? You got to look at what power do you have? What structure is there available? And when we look at that, we really need to look at two separate pieces of that as well. So the first side is what would be kind of like your nameplate and your design capacity. So if you think about, any electrical system, you're going to design an electrical system based on anticipated loads. And your building was designed based on the loads at the time, AC, house loads, lighting loads, individual building loads, all the different things have all been calculated into your system. So you have you're going to have an electrical distribution system that may have a main distribution panel that comes in, and then that separates into multiple small panels, maybe at each floor level, or, you just have this whole kind of system of wires and panels and all that breaks down. And when you look at that, right, it all ends up in a single typical circuit that goes out. So if you think of this real simple in your home, everybody's looked at their home electric panel, right? You're going to open up your home electric box and you're going to see some big double breakers that are for like the oven and for the dryer and for your AC. And then you can see a bunch of single breakers, and one's going to be lighting, one's going to be power outlets, and they all have amperages on them. And, you might have so for instance, on that, you might have a breaker that's got a 20 amp breaker that feeds your electric circuits, right? Your electric plugs, your plug circuits in your living room and dining room. Well, if you look, let's say you got 10 plugs out there. Well, what are you using? You might have one thing, lamp plugged in here or a lamp plugged in there. You might be drawing 2 amps out of that, but there's 20 amps in that, circuit. So there's a whole, there's a whole system that goes into this. And basically what happens is a typical circuit, that 20 amp breaker, it has to be, that can't have more than 80% of that as a load. So, if you had a 20 amp breaker, you can't have more than max load on that breaker of 16 amps. So when you look at a typical panel, you might see, well, man, I've got a 200 amp panel, but I've got, I add up all the breakers, I might have 200 amps on each side of added breaker space. Well, that's because not every circuit's going to be at max demand ever, maybe, right? Some of them will be, some of them won't be. And it's all based on the load that was calculated. And there's some guidelines, and then there's some actual, work, the engineering that goes into that. So when you're looking at your design side, your nameplate side, you have to pay attention to that. That's where you're going to start. And if I go into a particular building and I, look at let's say I look at a main distribution panel, and there's a 1200 amp main distribution panel. And then I go and look and there's 3 or 4 200 amp breakers in that. And those all 4 go off to 4 separate 200 amp panels. Well, I can assume by looking at that, I mean, obviously we do some engineering on this, but if that's the case, if I only have 4 200 amp breakers, then I'm only using 800 amps of the 1200 amps. So now I know I've got, based on nameplate and design capacity, I should have at least another 400 amps that could be doled out to other usage. So if everything was designed that way, you have the right power coming into that MDP, you have 400 amps of spare power. Well, anybody that knows this, if you own commercial buildings, especially older ones that we're talking about today, you can bet there's not 400 amps of spare power in your building. We know that. Very rarely are we going to find that scenario. We might find, typically what we see, and this is from what we've been involved in for over the years, typically it's very easy to put a few chargers in. It gets very difficult to put a bunch in. So when we're looking at just the nameplate and design capacity. So that's the first thing you got to look at. And oftentimes we're going to find out what's available based on some initial nameplate and design capacity. But the next piece that you got to pay attention to as well is what is the actual usage and demand? Because you could be, thinking that you don't have available power to add some chargers when you might actually have it there. Because when you look at that, let's go back and say that MDP now had six 200 amp breakers. So all 200 amps. So the MDPs is fully doled out. And then we go to a couple, maybe go to the panel that's feeding the parking garage, and we see, oh, that's a 200 amp panel that's feeding, the elevator, this, that, the other. We take a look at that 200 amp panel, and maybe in there, we see that we're really only using 160 amps, right? So that's, but then and that's maybe by looking at what's in the breakers. Well, when you actually go in and do some power logging and really pay attention to what the demand is, we might find out that we have maybe allocated 120 amps of that 200 amp panel to certain things, but we might find out that we're really only using about 80 amps of that. So that gives us some real actual usage and demand. So we got to pay attention to that as well. And this can be done a couple ways, right? So what we try to do is, a lot of times you can find out from your power company. Now, your power company's not going to be able to tell you down the line, but it can tell you, just from the high level, right? That's where we normally would want to start. If you look at your power, and let's say, again, in that building, we have a 1200 amp distribution panel. If we go back and look at our power reports and we find out that even in our biggest peak, we were only drawing 1,000 amps. Now we can go, wait a minute. Let's look back here then. Let's go find out where's that, there's 200 amp spare capacity right there. We've never hit that full demand. So let's figure out what's going on. So then you have to get into power logging, where you'll go in, you actually put some devices on each panel, measure what's really going on, so that you can then really understand what's happening. An easy way to kind of demonstrate this, to understand, is we all know a typical hotel, right? If you look at a typical hotel build out, there's going to be a house panel that feeds, right? Every hotel's got a whole laundry room, right? So we know what's in that laundry room, some big commercial dryers. Well, they're power hogs, right? We know those things are burning some power, unless they have a gas burner, but if, let's say they don't, but even if they have gas, they're still turning, they're running washers, dryers, right? So we know that in a hotel, that laundry's going on during the day, right? The maid service comes in, they strip all the rooms, they bring all the stuff down, they do they do all the laundry, boom, all done. Well, those commercial dryers and washers are not running at night. Maybe some other things running at night, but they're not running at night. So I know that from a hotel standpoint, I could go into that particular area and figure out how much of the power they're using during the day. And now I know I could actually grab that power from the building, because that's going to be spare power at night if I've studied everything properly, and use that power for the chargers. So maybe instead of having to add a whole new panel in or upgrade the main distribution panel, I can be like, oh, well, I can just steal the power out of this panel, right? Because it's not being used. So that's where we have to pay attention to the actual usage and demand of the building, because that can tell us what we really need to do. Like what we ultimately try to do at any place that we're trying to install EV chargers, right, is we want to minimize the upfront cost. So that the better we can handle this infrastructure, that's existing versus new, it's going to be better off for us, right? The last thing we really want to be trying to do is upgrading transform and things like that. So the foundation, the structural, not structural, but the electrical foundation, you got to start by looking at what's your nameplate and your design capacities, and then studying the actual demand. That's going to tell you what you have available today to do EV charging. Then from there, right, your team is going to design the right solution that fits and determine what you really need to do. Do you need to upgrade today? Do you need to plan for upgrades in 5 years? Do you have enough capacity? If done right, we never have to upgrade. That all depends on, understanding what that base load is. Okay. So that's the first thing you're going to look at. Next little thing I wanted to talk a little bit about here is understanding the installation and design. When you're looking at multifamily, when you're looking at things like this, retrofitting, understanding things like that, there's a few things that come to mind here that we run into. First is, where do we install chargers? So this can be easy or it can be super complicated. In the beginning, a lot of people, have opted to say, hey, I've got half a dozen visitor spaces up by the community center, or right when you pull into the parking deck, there's some, visitor parking. We're just going to throw them right there for now. Okay. Well, that works good when you have, a few EVs, but what about in the long run? If you have a building with 200 doors and we end up with 20% of your residents owning EVs, what do you do about that, right? Like, what do you start to look at, right? It's all something that has to be considered, even in a small piece, right? Like, was talking with my aunt the other day, and she has she lives in a little 6-person, a 6 condo unit. And so it wasn't a, huge deal, but one of the residents has recently gotten an EV, and she was just, telling me, like, well, they couldn't figure out what to do. This particular resident is using house power. He's just using a mobile charger plugged into the 110, and she was telling me about it, and she's like, what do people do? Like, because she's on the board, and they're like trying to figure out like what to do, and how to get ready for this in the long term. And obviously the first one didn't bother them a whole lot, but she's like, we've got to figure something out. So even in 6 units, there's, however many parking spaces, and she's got to, they've got to eventually figure that out. So what do? Like, and they have deeded parking. So that's where you start looking at this stuff, and that's where it kind of can get challenging, right? If you have deeded parking, so that means when I bought my condo, I've got parking space 32 and 33, right? Those are my parking spaces. Well, if I want EV charging, I want them in my parking spaces. So how does that work out? And then to add to that, right? And we've talked about this in the past, but if you're in a right to charge state, I have the right, if I'm in a right to charge state, I have the right to put charging in my deeded parking space. And you have to allow me to do that. I may have to pay for it, but you have to allow me to do that. So there's considerations on that kind of stuff. Deeded parking is going to play a lot into it. When we get into, when we talk a little bit about more power management, if you have deeded parking, you really, really need to make sure you're working with the right people. Okay. That is, to me, that is one of the biggest challenges, is the deeded parking scenarios. And we'll talk about that a lot in power management, but that is a very difficult solution, right? Because now I have to put, because especially like a right to charge state. Okay. If I'm in a right to charge state and I have deeded parking, now I know that, okay, Tony wants a charger, I've got to have charging in spot 32 for him. And then Donna wants charging, she's in spot 48. Well, they're nowhere, 48, and somebody else is in charging spot, in spot 3. Now you have charging all over your parking structure that you need to provide. So you almost need to be prepared to put a charger in every single stall. That can get really, onerous, and thinking about capacity for that, right? Like that gets overwhelming. So that's why you really need to make sure you're using the right partner if you have the deeded parking. So we got to think about that. Like I said, a lot of people are starting out using kind of common areas and visitor parking, but that's not a long-term solution. If you have open parking, obviously it's much easier. You could even, if you have open parking, a lot of times what we see people doing is kind of taking up some, like, maybe not necessarily preferred, but certain areas of parking. Obviously you want to put it close to the power panels and things like that. And then they'll assign that parking, based to EVs only and things like that. So there's ways that, ways to deal through this, right? And if you have different things, you just want to make sure you're considering that. One of the things, that big thing I wanted to mention though, is understand the difference between open parking and deeded parking. And then, make sure you're looking at short-term versus long-term. Because again, I might be able to solve this, if I come to you, even think of surface parking, and I have a multi-building complex for, condos and all. And I've got, 6 buildings and a community center. Today, I might say, well, look, I can kind of satisfy my residents. The community center is kind of central to everybody. Let me put a row of 6 chargers in there, and then, at least everybody has a place to charge. Well, if all of a sudden you have 6 or 8 EVs at every one of your 6 buildings, and they're all, now they're going to start wanting them distributed out to each building. So think about the thing over time and all that, right? And how it grows out. So where to install is important to look at from a high level, especially with deeded parking and especially in garages. Okay. We don't want to be running stuff all over the place if we don't have to. Now, when we look at the installation itself, a lot of times, people get concerned how to install it, what to do. If we're in a parking garage, it's a retrofit, right? And so we recommend, sticking with surface mounted conduits and things like that. Trying to get in and hide all that can get very costly. Some people do it. We have some that will tear open some walls or, stuff like that. Obviously, if you're cast in place concrete, you're not really tearing up walls. So you probably already have some exposed conduit. But, look at that. But you can make sure that you're providing good guidance to make these things look neat. Like, we don't have to, you don't need people running things all over the place. I've seen pictures. I've seen pictures of great work. I've seen pictures of horror stories of these things going in. So make sure you're giving some guidance there to make sure they look neat and clean. You can even come in and paint them after the fact. And there's some raceways you can buy that look a little better. You've seen those inside buildings as well. So you can look at all that. Surface parking is a little easier, right? But you have to look at where your power locations are. If you're looking at that 8-unit complex, right, or 6-unit complex, and I've got maybe, each unit has some parking up by the building and a parking across the way, kind of, often how they are. Maybe I think, I'll put chargers in the middle of those parking spaces. Well, if your power's on one end or the other, then why not move the chargers closer to the power? So those are the things to look at there, where they are. And then as you're installing, make sure that people are paying attention to structural issues. Parking garages are often post-tensioned or pre-tensioned structures. So you've got, you've got structural tendons inside there. When you're going from level to level, you might be core drilling through that. Make sure that, that's being done right. It's being engineered, and we're doing the radar, the ground penetrating, the radars of those things. And we're, making sure we're allowed to drill where we're allowed to drill. So don't just have somebody out there getting out a core drill and, popping holes in your floor. And make sure that you're paying attention to fire safety. Often those floors are going to have, fire requirements, people coming in and out of electric rooms. Electric rooms are often going to be have firewalls, fire rated walls. So they could be 1 hour, 2 hour smoke walls, all that kind of stuff. Make sure that's all being taken care of, because the last thing you want to do is have somebody come in, penetrate your 2 hour firewall, and not replace it back in kind. Okay. So it doesn't matter. We can penetrate those things. They all get penetrated all the time. It's just that you have to put the right sealant back in there. So make sure you're paying attention to all that. Uh, you know, the more complex your installation is, the more I recommend that, work with a good engineering firm or a good, your service provider. If you have a good charging service provider and they recognize everything that's going on, and they're probably going to bring in a good engineer that's going to pay attention to this stuff. So make sure you're paying attention to that, especially as you get into a bigger, more complex build out. And the last thing on the design considerations that we always get into is whether or not we need a new service brought in by the power company, or if we have to upgrade our transformers or our main distribution panels, things like that. So that is a big thing to consider. And a lot of places, they are going to need, they are going to need more power. Maybe not today. Most places that we get involved with, we are able to provide a solution that lasts for a while, that's going to last for a little while. Like we're not, every now and then we run into some places where the panels are just overloaded already, or they're in need of an upgrade anyhow. So we do occasionally run into that, but that's rare that we can't get at least some level of EV charging going. And what we try to recommend to everybody as much as possible is to get something going before you get too crazy in over designing a solution. Okay. But this is going to happen. You're going to have buildings that need some upgrades. Maybe not today, but like I said, in the future. So when you do that, you need to start thinking about, how are we going to handle that upgrade? Are we going to, can we bring in a whole new service? Because if it's cleaner, and a lot of times power companies like to do this, they prefer this, but if it's easier and cleaner, if I can call the power company and say, hey, look, I've got a current building load with a 1200 amp distribution panel. I need to add some chargers. I'd like to just bring in another 600 amp service over here. Can we do that? And sometimes that's going to be easier and cheaper than updating your entrance for your 1200 amp panel to an 1800 amp panel and add a new 600 amp EV charging panel, right? Maybe we can do that. And then it becomes easier to control, easy to do power management on, and all those kind of things. The ideal way, if we can get it done, and the way we always approach it first is a new service entrance. Just gives us way more control over those chargers and what we know is happening, and avoids us from getting into any, trouble with the building side. And you never know what comes, what's coming in the future. Lord only knows, right? Like we don't know what the demands are going to be, with all the different stuff that's happening, AI, things like that. We never know what an individual house load might be. Today it might average certain amps, and that might go up next year or something. Who knows? So the more we can keep that separated, we like to, but sometimes the power company just can't do that. Sometimes your building constraints don't allow a new service entrance to come in, period. And so you have to go and say, okay, we've got, here's our existing system. What are we going to do to upgrade it? So that's the other part of, installation and design considerations. Now, to wrap it all up, and actually to relieve the tension a little bit, okay? If you think about everything we talked about so far, it kind of gets complicated, right? And it could seem like, ooh, this could be a lot more than I expect. Well, the good news is power management is available. Like there is power management that can do a lot to help offset some of these challenges. That's the good news. So the software can make a big difference. So I'm going to talk a little bit about the value and the why we use power management, why it's important. So a typical power management solution that's out there today, we're going to talk about two different types, but the bulk of them, the main type of power management that's out there, and it's what our current software works on, is we take if we look at a typical installation of a location, and let's say, I come check all your power, we find out, well, wait, okay, we've got this house panel here. It's a 400 amp panel. Currently, nothing's really in it. There's a little lighting circuit in there, but we've got all the capacity we need in this 400 amp panel. So I might say, okay, in that 400 amp panel, I can use 320 amps, which would allow me to basically install like 10 chargers set at 32 amps. So now what I can do is, okay, so that is now the max chargers that I could do without power management, because every charger, when it pops on at 32 amps, will draw, and we'd be up to 320. Now, we know that not every car needs needs a full 32 amps over a 10-hour period to get fully charged. So what we do is we use power management to add more chargers to that. So we also know that if we have 20 chargers installed, not all of them being used at the same time. So we could put 20 chargers in, and if only 10 are being used at any given time, they still never overload my panel, right? So what I do is use a basic power management system that says, never let this group of chargers take more than 320 amps. So if all of a sudden 20 cars plug in, it's going to split all that power and give each charger 16 amps instead of 32 amps. So it just splits it all down. I still didn't overload my panel. I didn't have to upgrade my panel. I didn't have to add more electrical capacity. I just put power management on it. So that works fabulous, because now I've just put enough chargers in, and depending on your design and how it's being used, 20 chargers in a multi-family scenario can probably, depending on how, kind of your usage and all that, if it's not specific deeded parking, if it's open parking, 20 chargers, we think will serve, every charger can serve anywhere from 4 to 8 residents, depending on, what your driving habits are of your residents. So 20 chargers, you might be able to cover even up to a 200 door facility with everybody in the facility driving an EV. Okay. That we don't totally know yet, because we're not, we don't have that historical data, and your place is going to be different from the guy down the street. So we don't know that for sure. But so you can see how the basic power management works. It takes existing capacity you have, allows us to put more chargers than the theoretical or design nameplate capacity by lowering the demand of each charger as more people plug in. That works great. It's a nice, easy cap, but it doesn't go back and help us with grabbing or utilizing maybe some actual capacity that's sitting out there. And also you have to have that upfront, 400 amps of free panel space, right? Which is not always going to be the case. So the next part of power management, which it's newer, it's coming out. We are launching our version. Our software is upgrading with this new dynamic, what we call live or dynamic power management. We're launching that second quarter of this year. And what this does, this live power management, is going to track your actual building load, right? So it's going to take, through monitors and sensors, it's going to track your 1200 amp distribution panel and know how much power of the 1200 amps is being distributed through your building at any given moment. And then it's going to track each individual panel down the line to see how much is being used at each individual panel. And it can now control the load of chargers based on the full building load. So this allows me to go back to the beginning when I went and studied your actual usage of your building. And let's say you do have a 1200 amp main distribution panel, and through our power reports and our power logging and everything else, we've figured out that on an average night, you're only using 600 amps of those 1200 amps. Now I know, okay, cool. I've got 600 amps of power that I can now use almost every single night to send out to my chargers, sometimes more than 600 amps. So I put all my power monitor in. I can go into your MDP and grab a couple breakers out of that, throw them into my panel, whole new panel for all my chargers, or I can go to each individual panel, maybe distribute it through your parking deck and grab space in each one, because I can monitor this down to the individual panel level as well. So if I look at that and say, okay, now instead of needing a design capacity of 400 amps, I'm able to take an actual dynamic usage capacity of 600 amps and know that if I know that, I know my system is now going to adjust accordingly. So in the morning, when people start waking up and that demand starts to go up and up and up, and all of a sudden, I no longer have 600 amps, I only have 500 amps, I only have 400 amps. As the demand goes up, my system will automatically adjust those chargers down. And if it got to the point that at 9 o'clock in the morning, there's only 100 amps excess in your building, then my system is only going to allow 100 amps go out to those chargers. By doing that, I'm now picking up all this excess power that's sitting there overnight. So think about the example I said with the hotels with the dryers, right? So if I have, let's say I've got 3 dryers in a hotel that run all day long, and they're on 60 amp breakers or 80 amp breakers, I just picked up 240 amps that I can throw out to chargers. At a hotel, I got overnight parking. If I put 24 to 32 amps into that charger, everybody's going to get up in the morning with a full charge. So guess what? I can put 8 to 10 chargers without adding any capacity, just by using the spare capacity from those dryers. So that's what this new system does. So this allows us to do a heck of a lot more, right? This was actually designed to solve that deeded parking scenario. Okay. Doesn't help, we still got to do a lot of infrastructure work, but now I don't have to, if I've got a 100-door condo, I don't have to design to have enough power to constantly power 132 amp chargers, because I know with power management and charge curves and what the average user is going to need, I probably only need to give them I could charge all 200, with about 12 amps, 15 amps, maybe 20, on average, if they were all being used. So we don't need the capacity now, is the value of this dynamic load management. So I wanted to just share a little bit about that. And that's a little bit of plug about us, but we're not the only ones doing it. There's other companies out there doing it. So make sure you look around. But I wanted to make sure that you knew that was coming, because many of the current solutions just do that basic management that I was talking about, that's been out forever. This new live and dynamic power management, it's a little bit more involved. It's a little bit more in depth. Obviously, we got to track your usage. But the good news is it's out there. More and more people will be developing the same solutions. We have it, like I said, coming in second quarter of this year. We'll have it live. It really is a game changer for this type of scenario. Allows us to really maximize the amount of charging we can add on existing infrastructure. So that wraps us up for today. Just to sum it all up, like when you get ready to update your property and get EV ready, make sure you're planning properly. Get the right provider involved early on, right? Don't just, like, I know a lot of times a lot of companies work with engineering firms, and you'll say, oh, reach out to an engineering firm. I really recommend that do that with your engineering firm is fine if you have one you like and trust, but make sure that you're engaging with an EV charging expert as well. A CPO, get somebody like Stay in Charge involved early on as well, because sometimes engineering firms aren't up to date with all the latest technology as well. So by understanding exactly what's happening in the industry, your EV charging service provider will be able to bring more details into it and help the engineering firm to make sure that you're designing for what's there today and what's coming down the, coming out in the future, right? So that's what you need to make sure of, right? Get the right provider, conduct some upfront research to make sure you're taking advantage of all that untapped power in your building. With this new power management, using dynamic power management, you really can get a lot of chargers installed on your existing building for most places, because like you've got a lot of things that are going on in a building when it's busy that are dormant at off times. So we're just taking that power when it's not being used, and we're shooting it off to those chargers. And this happens in really quick intervals. It's like, we're monitoring power at like every second of the day, right? And so, we don't need to have like an hour of time. Like we can shoot an extra 5 amps to the car for 30 seconds or 30 minutes, just depending on what's going on. So it really is going to help change everything there. So make sure that you're getting the right people involved to make sure you're not leaving untapped power behind. All right. That's all for this week. Make sure you check us out. Next week, we're going to look into a little bit of protecting your assets, looking at insurance coverage, things like that. So as always, thanks for joining me here today. Make sure you share this, like it, send me comments. If you don't like it, give me a thumbs down. That's cool too. Everybody's, out there. But share it with people that let me know what you think. If you got questions, as always, reach out and give us some 5-star ratings and subscribe so we can get more people listening and get this thing growing some more. All right. That's all for today, folks. Thanks again, as always. Hope you learned something new today, and have an amazing weekend, and we will see you next Friday.